Okay, student, yesterday we have studied about range of inverse trigonometric function, right? How to find out range we have studied, and those range was limited, right? You cannot take everything from the trigonometric function. The domain which was for trigonometric function becomes codomain, but in this case the domain of trigonometric function you are going to make range, but in that range you cannot take all the element of that domain, right? Some particular only we can take, then only inverse will exist. So I have already shown you why in inverse trigonometric function the range are taken like that, limited one. Okay, so the reason was for existence of inverse trigonometric function. Okay, now we will study how to represent a inverse trigonometric function. Then we will study composition function identities. This we have already studied in first chapter only. Okay, this identity I will show you which one it is. Next we will study inverse trigonometric function identities for negative inputs. Like for example in class 11 you have studied, right? For trigonometric function, what you have studied, sine of minus x, what it was, minus sine x. Remember this identity? Whenever your input is negative value, the negative sign is to come out. In case of cos, I told you, right? Cos will eat up this minus sign, and the proof also I have given how we got this one. So cos of minus x is always cos x. So these are identity for trigonometric function. So same way for inverse trigonometric function also we have some identity. So we will discuss on that. So next will be relationship between sine, cos, inverse, tan inverse, these things. Like for example, sine x, normal trigonometry. What we used to write. This can I write? 1 by cosec. Sine, I can write 1 by cosec, right? Now, in case of sine inverse, will it be same? Can I write sine inverse 1 by cosec inverse x or not? We will check whether this will be correct or not in case of inverse. And if it is not correct, then what will be the correct answer for this? What will be the relationship between sine inverse and cosec inverse? Like that, we will try to find out the relationship. Okay. So these are the topics we will discuss here. So first thing you see, in first chapter we have studied that if a function is, this is fx, you can consider, okay, fx equal to y equal to x cube, suppose. Okay, if this is a function, then how we used to find out inverse? We have studied in set builder form inverse. How we used to find out? Just keep x alone now, and it will give you whatever gives out, that will be your inverse. Means what? You can see here, when I will put here input 2, what I will get? Y equal to how much I will get? 8. Now when you will take inverse, what will happen? I will take this one as input. You can see from the arrow diagram also I can explain. When I take x equal to 2, your image is what? Y is your image, right? 8. Now when I will take inverse, what will happen? I will take this one as input, and I must get output, that is image of 8 must be 2. I must get this one, then only it will be inverse function, remember? So when I will put input here in inverse, I have to get 2 image. You can see y, if I take, in case of this one, x, when I take input I took 2, output what I got? 8. Now input I will take 8, and output how much I will get? You can see when I will take y 8, what you will get? Cube root of y will be how much? Or cube root of 8 will be how much? Obviously 2, right? So x equal to 2. So you can see when you take input here 2, output you got 8. When you take inverse, when you take input 8, output you must get 2. Then only it will be an inverse. You can see, you can understand that one from the inverse function also. You have already understood this one in first chapter. If this is a function, its inverse will be something like this, right? 2 image is 8, so in inverse what will happen? 8 image, this will become domain, right? And this will become codomain. 8 in image will be 2. So that's what we are getting here, right? Now same way in trigonometric function also. If your input, for example, y equal to sine of x. So if I draw this arrow diagram also, see carefully. This is your sine function. Okay. So input, if I take x, this will be your y, right? Now see here, I will take one input. Now see, in case of sine, what is this one? Angle, right? Remember, this will be angle. So if I take, suppose here, pi by say 2. If I take pi by 2, what will be its image? Sine of x will be, this will be what? Sine of x, right? So if your input is pi by 2, put x equal to pi by 2. What I'm teaching here is how to represent. Like for example, in case of this kind of function, y is equal to x cube. So it's inverse how you used to write. X equal to cube root of y. Very simple. Cube you will bring this side and this will become your inverse. Now same way in case of trigonometry, how you will write. If y equal to sine of x, okay, then x will, what you will write here? Will you bring sine this side? Now sine does not have any meaning without angle, remember. Okay, so sine you cannot bring this side because sine itself does not have any meaning. So if you bring this side, see, according to our rule, what it is, y by, it will become y by sine. Now what is the meaning of this one? Only sine alone does not have any meaning. That's why we cannot bring this one this side. Okay, I hope you can understand. So you cannot write x equal to y by sine because sine itself does not have any meaning. Then what we will write here? Okay, x equal to what we will write such that this will give you the output here. Okay, so we are trying to understand that one only, how we will represent the inverse here. So see carefully, when you put pi by 2, what will be your output? 1, right? Sine of 90 is how much? 1, right? So 1 will be your image. Now when you will write inverse, how you will write down? So this is what I'm doing. Put x equal to pi by 2. So input I have put pi by 2. What I will get? Output. Y how much I will get? 1. So your input is pi by 2. Output is 1. So same way here, when you will put this one, you have to get what? Y if you put 1, you have to get x equal to how much? Pi by 2. Can you understand with this? Here when you put input 2, output you got 4, 8. Now here when you put this one in inverse, 8 we will put it as input, and output what we have to get? 2 we have to get. So same way here, if you put input pi by 2, output we get 1, right? So in inverse what will happen? You will take it as input and output you have to get this one. Then only this will be your inverse function. Okay, so pi by 2 I have to get. Now what I will write here such that I will get pi by 2. So see carefully. So in inverse, how we used to represent. So in your normal trigonometry function, your input is pi by 2, output is 1. So in your inverse, what it will be? Input will be 1 and its image must be pi by 2. Now how I will represent this function? Now see here. This is what? Inverse of this one, right? Inverse of this function. The inverse of this function, how is to represent? Can I write sine inverse like this? Remember, if this is f, what we used to write down this for? F inverse. Like that we used to represent, right? So representation can I give like this function? If sine is a function, then sine inverse will be your function here, inverse function. So how you will represent here? See, if this is x, this will be y. Now this codomain become domain here, right? So this will be what? Y. Yes or no? Now this what you will write? Obviously this is your x, but x you cannot write, right? Because function is this one, and image how we used to write? Function with this element. So how you can write down this one? Sine inverse y. Can I write like this? And this is what? Your x only, right? I hope you can understand. This set is this one only. So x equal to what? Can I write this one? Sine inverse y. So I can write this one as sine inverse y. I hope you can understand. If y is equal to how much? Sine of x. This is just a notation. I have explained you with the help of arrow diagram. Some student might be thinking like that sine I have brought this side, that's why sine inverse. Usually what we used to write? 1 by 2. 2 I can write, this one I can write 2 inverse like that, right? You can understand in that way, but the meaning is not this one here. Okay, sine inverse, here 2 inverse have meaning. We can find out. This one is 1 by 2, half. We have value, this one, right? Meaning, but this does not have any meaning. Sine only inverse does not have any meaning. Sine inverse means you will write like this, 1 by sine. What is this one? Sine alone does not have any meaning. It must be with angle, because with angle only it used to give you the ratio in right angle triangle. Remember, perpendicular by height. But if you have angle, then only it will give you that ratio. Otherwise, sine itself does not have meaning. So you cannot try to think that sine you have brought this side and that's why it becomes sine inverse. Not like that. Try to understand from this arrow diagram. Okay, so whenever you write down y equal to sine x, we can write this one as x equal to, you can think in this way, sine I have brought this one, that's why you can remember in this way, but the meaning is not that. Remember, x equal to sine inverse y. So whenever you have y equal to sine x, x you can write sine inverse y, means sine you think that you have brought this side, then it will become sine inverse, like that you can think. Okay, so why I'm showing this representation, the reason is when we solve inverse trigonometry, for example, some value will be given. So this meaning is what? When you put here 1, x you will get pi by 2. Okay, after solving, sine inverse 1 is pi by 2. Now see, these values we have not studied. Like for example, in normal trigonometry we have table, right? 0 degree, 45, 30 degree, all this table we have. But for inverse we didn't study till now tables and all. So when you will solve this one, obviously to solve this I will convert this inverse into normal form. For example, if they give you like this, y equal to sine inverse 1 by 2, they give you something like this, then how I will solve this one? Why I have to find out how you will do that. So first what I will do, I will convert this one into normal trigonometry. This can I write like this? Sine inverse, if I bring this side, what it will be? 1 by 2 will be alone. Sine inverse, when I bring this side, you can think in this way, but I am not bringing this. Okay, this is from this definition only. Sine of y, can I write like this? Because see, from here we have already derived this. Y is equal to sine x, then x will be what? You can bring this one this side, right? You can think in this way, x will be sine inverse y. So same way, see, sine of, this is your x, suppose, in case of this one, this is your y, suppose. Okay, this is your x, this is your y. You can think, you can compare with this. Then you want to find out this, right? So what you will do, sine you bring this side, it will be this one or not? Sine inverse y. See, sine inverse, this will become like this, right? Sine inverse y, sine inverse y alone. Can you see? So if I can write from this to this, then obviously from this to this also I can write like this. So see, when I convert into normal function, then it's very easy to find out. 1 by 2 equal to sine of y. So sine of what angle will give you 1 by 2? Yes, sine of 30. Right, 30, that is in terms of radian, I can write pi by sine of pi by 6 will give you 1 by 2. So your y is equal to how much? Can you see if you compare this one? Therefore y is equal to pi by 6. Now can you see, to find out this y value, to solve this y value, means this one, what I have done, this inverse trigonometry function I have converted into normal trigonometry function. Can you see, I brought this one this side like this, then I have find out solution from normal trigonometry. Because for inverse trigonometry we have not studied any table or something like that. Okay, for normal table we know, normal trigonometry function we know. Okay, that's why we have converted inverse into normal and then we find out solution. Obviously some student might find it this one strange, right, what we are doing. Now since you are doing for the first time, that's why it might be a little complicated right now, but once we will study more and more on this, because identity also I am going to explain in this way only, so you will understand there much better. Okay, so for the time being try to understand a little bit, it's fine. Okay, so this is just representation I have shown you. Okay, so when you have y equal to sine x, normal function, y equal to suppose, or if I write this one as fx like this. Okay, so these are your representation. Your y is denoted by fx, right? Function of x, you can see. So we used to write in remember in first chapter we have studied function, how we used to write f of x, right? F of x equal to y equal to suppose sine x, right? So it's inverse, how we used to write down in terms of f, we used to write f inverse y. Remember we have studied Those who have not seen the first chapter properly, I told you maths are interrelated. If you don't understand the first chapter, then obviously you are not understanding this one at all. So first chapter is very important. In that chapter only I told you, to understand second chapter you need to concentrate well in first chapter. I told you there only. So if you haven't watched those videos, then you will not understand all this. Okay, so this is your F. Okay, so this we used to denote by x, this we used to denote by fx. Now is inverse how we used to write down. This is suppose a, this is suppose b, then its inverse we used to write like this. This become your domain here b, this become your codomain here a, right? And the function how we used to write, its inverse we used to write f inverse like this, right? And this will become your, this is your y also, right? This will become your y, this is your y, right? This side is this one, so this is your y, this is your x. Now x we cannot write. X, what we can write? X equal to this one, what we can write? F inverse y, function with this domain element. Can you see? Function with this domain element. That's why f of x, this is the notation here. So here what will be the notation? This function with element. So that's why you can see fx equal to sine x. So in inverse how we used to write? F inverse y. Now this was fx, this is f inverse y, element will be y here. Now is it clear? With the help of arrow diagram try to understand. Okay, f inverse y equal to x equal to, just now we have studied, right, in terms of trigonometry function how we used to represent sine inverse y. X equal to, if it is y equal to cos x, then x equal to cos inverse y. If y equal to tan x, x will be tan inverse y, like that. Okay, these are all notation. So try to understand this one. To solve, again I repeat, inverse we will convert into normal trigonometry function and then we will solve. Okay.